Good
Good
morning,
morning.
everyone. Welcome to the C&E Sales Monthly Webinar Series. I'm Jeff Butler, the manager of the technical group here at C&E. Today's webinar is titled the ACSI Integrated Servo from Tolomatic. Our presenter today is Tom Watson. Tom's one of our motion specialists here at C&E. He's located up in the Fort Wayne area. He spent his entire career in industrial automation. He's been on board with C&E as a motion specialist for 5 years now. So just a few housekeeping items before we start. If you have questions during the webinar, please submit them using the control panel on the right side of your screen, and we'll address them at the end of the session. If you don't see that tool, click on the red horizontal arrow, and it'll open up that dashboard that you can see. Everyone who's registered for the webinar will receive a link to the recording. Please be sure to attend next month's webinar hosted by John Pipkin. John's one of our automation specialists out of the Nashville area, and John's topic will be superior wireless communications for industrial Internet of Things applications. And it's going to be, I think John's going to be focusing on the Banner wireless products. That webinar will be hosted on March 9th at 10:30. So with that, I will now turn the webinar over to Tom.
Good morning, everyone. Thank you for joining this webinar on Tolomatic's new ACSI drives. The agenda for today is first a few facts about C&E sales to let you know who we are and how we support you, and then some facts about Tolomatic, and then we'll dig into what is an ACSI, why to use it, how to use it, and a little bit more about where you can find information on those topics. C&E sales, we have a strong team of dedicated associates who strive to meet your critical needs. We work closely with manufacturers that we represent to provide you with the best service and support in the business. We have over 100 employees. 40 of those are field salespeople. We have 18 technical specialists. And as you can see from the slide, quite a bit of capabilities. Here's a quick look at our salespeople. We firmly believe that salesmen should be out in the region working directly with our clients. And so they're distributed over Ohio, Indiana, Kentucky, and Central Tennessee, giving our customers fast response. You can count on us, and one of the keys to the success at C&E Sales is our commitment to service to our clients and our business partners. Our team of highly trained professionals work to meet all of your needs. We have a customer service group that's there to assist you with quotations, tracking of orders, or finding information. Please don't hesitate to contact them if you have any questions about your account or your orders or how they can better serve you. We're really proud of our logistics group. They have developed proven methods to ensure that your order is filled promptly, correctly, and packaged to arrive when you need it. Our team has the highest records in the region for prompt, accurate shipments. They work very hard so you don't have to. I'm very proud to be a member of C&E's technical support team. Our ongoing training in our products and industry standards allows me to help our clients implement the latest technology as well as maintain our existing assets. Let us help you with your industrial automation needs, whether that's with sizing of new equipment, evaluation of existing equipment that you have, assets that you have in your facility that need either service or support, or ongoing training to help your staff better meet your needs. As you can see, we have a large technical support team. They cover automation, vision, safety, and my group, motion. Education is a good part of our C&E support for you. We have webinars like you're hearing today, as well as on-site training either at your facility, at our Dayton headquarters, or in regional events that we host throughout our territory. We can also help you with setup training directly by our suppliers, such as Tolomatic. We have webinars, as Jeff mentioned earlier. Uh, the second Thursday of every month we have webinars coming up, but we also have some training events over the next 3 or 4 months that are pre-scheduled and will be held in your areas. So why work with C&E? We provide answers that work and stand behind them. We work to stay within your budget and deliver your projects on time, and we can assist in your automation projects from the product conceptualization, system architecture, bill of materials generation, design of alternatives, training, and startup and commissioning. So please consider C&E sales for all your sensor, safety, vision, motion control, automation, and now robotics needs. A little bit about Tolomatic. They've been in business since 1954. They have a strong reputation in providing actuators and gearboxes, mechanical, pneumatic, and electric products used to make motion. They have a broad range of products, but they're also very good at developing custom products for special needs. So if their standard line doesn't meet your requirements, please contact us and we'll see if we can work out a solution from Tolomatic. They have original products were the power transmission products. Right angle gearboxes is where they got their start, and then they later introduced clutches and brakes. They still continue to refine those products and innovate in those areas. The next kind of area that they developed was rodless air cylinders. This was a new concept in the industry back in the 80s, 70s, and 80s when they came out with cable cylinders, which save half the distance of a conventional rod-style cylinder and provided a lot of flexibility in mounting applications. They still continue to develop rodless air cylinder products and pneumatic thrusters, but we also have linear equivalents of most of those products that we can offer. And that's the area that we deal with mostly, and which is the focus of this webinar, is electric linear actuators. Offer many advantages over pneumatics and hydraulics. They're smoother, quieter operation. You can control a position, speed, acceleration and deceleration, and force very precisely. Energy conservation and low environmental impact are two other areas that linear actuators excel at. They're flexible and they have rapid reconfiguration. All make electric actuators the thing of the future available right now. Rodless actuators make use of ball or roller screws or timing belts to move carriages along a track or set of guide rails. They offer high precision and the ability to combine units for multi-axis applications. Tolomatic also offers rod-style electric linear actuators. As you can see from the slide, there's several different options there, including hygienic cylinders shown in the center, which meet food, beverage, and pharmaceutical needs. They also have recently added some very high force units to their lineup, so we can get up into thousands of pounds of force with their cylinders. Here's some examples of other cylinder applications that they have, which incorporate not only the motor but also drive connections in the cylinders. Tolomatic offers some very good tools for your use available on the website. One is the actuator sizing. This allows you to go in and size cylinders based on the speed and force that you want to have for your application. They have a CAD library where you can download in 2D and 3D formats all of their actuators and motors. Your Motor Here program is an alternate to using Tolomatic branded motors, where you can size third-party motors to apply to their actuators. And they have a wide variety of motors that are supported. And the Tolomatic ebook is a very handy reference for learning about how to apply linear actuators. So the website is at tolomatic.com. Their info center has the CAD libraries, catalogs, also some very good videos on how to use products, including the new ACSI drives. So I'm going to give you a quick presentation on the capabilities of the software, how the system is configured and works, but you can find much more detailed videos online at the Tolomatic website. So Tolomatic ACSI, to learn what it is, we now go to a Tolomatic presentation. So exit this one, start this one. You start this presentation. So Tolomatic's new ACSI integrated servo motor is available in two frame sizes, a NEMA 23 and a NEMA 34. And the general concept is to put not only a servo motor, but also the servo drive and controller all in one nice little package that you can order in combination with one of the Tolomatic actuators. So you can order one part number and receive an actuator along with the servo motor and controller, all as one pre-tested, pre-assembled device. This saves you time in assembly, time in ordering, complexity of ordering, as well as ease of installation. There's two basic styles, a basic format which is usable with either digital inputs, outputs, or analog inputs, and then Ethernet options that allow you presently to have Ethernet IP or Modbus communications. Eventually will include Profinet and EtherCAT. The drives run from 10 to 60 volts DC. 24 and 48 are very common ones, but it can go up to 60 volts DC. These are IP65 standard protections, so they're very rugged and robust and dust tight. All the connections made to them are with quick disconnect fittings, and we'll show you those in a couple minutes. It is available with high-performance industrial Ethernet with dual ports so that you can daisy chain from one drive to another. Also built in is a USB port that you can use for direct programming of the drives and commissioning. Basic version does include analog and digital control. The Ethernet-based units have that as well as the Ethernet control system. There's five basic ways of operating, and we'll review those in a couple minutes with the software. Pneumatic is intended to be a cylinder replacement, so pneumatic valve would typically have either one or two, sometimes three solenoids to determine position. Likewise, one or two or three inputs can be used to control the servo. Index moves can be pre-programmed to move through a variety of positions, up to 4 positions in the index move system. With Ethernet, you can basically have unlimited moves or force control. You can also use analog position. This is a very handy feature if you want to follow an analog sensor and adjust the position of the drive accordingly. You can do that with the analog input. Or the other option is to go with rotary operation. So you can use this motor with any sort of rotor application, such as a conveyor belt. If you want to drive a conveyor and then divert off of that with Tolomatic actuators, you can do that. You could use it for pumping applications. Very flexible in a rotary operation. Some of the features that we have on here, we have digital I/O. So if you look at the corner, you have some quick disconnect fittings here. There's 4 digital inputs, 2 digital outputs. These are optically isolated, 24 volt DC. You have an analog input which can be configured for either 0 to 10 volt DC or 4 to 20 milliamps. We have an input power supply. This is to run the motor and can, as you see, it can range from 10 to 60 volts DC. Down below we have dual Ethernet ports. You can run in and run out to the next drive if you have multiple drives in an application. On the top is this USB configuration port. This is where you can directly couple your laptop or desktop to the drive for configuration with the Tolomatic software, TMI software, which we will review shortly. Again, IP65 for protection of dust and low pressure water jets, and in two sizes, NEMA 23 and NEMA 34 standards. Here's the dimensions. As you can see, the smallest one is about 6 inches long, 4 inches tall, 2.5 inches wide. The 34 is a little bit longer, 6 inches long, 4 inches high, and 3 1/3 inches square. Connectors, as you can see, we have a 12-pin I/O for the analog in and out and digital in and out, the 2 Ethernet ports, the micro USB on the top, the power connector, and all connections meet the standard IP67 M12. There's some status indications on it. On the top is an enable and a fault LED, and then you have Ethernet connections and error and run mode indication. We have multiple integration options for the PLC. Siemens will be available shortly in Profinet. Currently there's Ethernet IP and Modbus TCP. We also have digital and analog I/O, so you can directly couple these to PLCs. And again, these can be ordered pre-mounted on a number of Tolomatic actuators, from both rodless and rod style actuators. And in that case, you would order one part number, would have the drive pre-mounted, pre-configured on the actuator. Concerning integration with Rockwell Automation PLC customers, there's seamless Rockwell Ethernet IP integration. We have add-on profiles that we can drop in to the control logic software. Ethernet IP ODVA is conformant, and it's past their testing stages. So we have drop-in and add-on instructions that can be used to communicate directly with the device and control it. As you can tell from pricing, it's pretty, and these prices do not include the actuator, but do include the drive in the two sizes, the NEMA 23 and the NEMA 34. So the basic can be had for under $1,100. If you add the Ethernet, it's maxed out at around $1,600. But also available are I/O cables, power cables, gearboxes in three ratios, 3, 5, and 10. We can order an inline brake assembly if you have a vertical application. You need a holding brake to prevent load from falling. That can be added. And then power supplies and 48 volts are available from Tolomatic. That concludes their presentation. So I want to switch back at this point and show you some of the software and some of the hardware. As you can see from my webcam, I have a Tolomatic RSA cylinder. This is a linear rod style actuator. I have it equipped with a small I/O box so I can manually operate the device. Switch 1 is an enable. Switch 3 and 4 are used to select different positions. and then switch 2 right now is a start motion. However, I've got to move the software to digital control. So now I can select different positions and switch back to that. But we'll go through the Tolomatic motion interface software, and this is software that's used for the ACSI. It's also used for the AC controllers. Tolomatic has two options for servo control. One is the ACSI, where the drive and the controller are built into one package with the motor. They also have a technology where the motor is separate from the controller, and the same software is used to configure those as well. But we're going to focus on the ACSI today. So in the software, when you first go to load it up and boot it up, you can connect to the drive using either USB serial, which again is a USB connection that goes in the top of the controller. You can, if you have an Ethernet drive, you can connect over Ethernet, or you can configure offline. We're connected with the USB on this unit. Let me disable the drive here. So go back to here. It shows the model of the unit that's available, the MAC address, so that you can set up for Ethernet connections. We've set it up for, let me disable this drive here, there we go. If the drive is disabled, which I had neglected to do that, we show the actuator. It's an RSA 24 frame, has a ball screw that's an SN04. The stroke length is 6 inches in our case, and it has what's called a reverse parallel mounting, where the motor drive is coupled to the linear actuator with a belt, and it's parallel. The motor is parallel to the actuator, as you can see in the webcam over here. And the motor option is an AMB XC1A1. If you go to the motor, this allows you, if you are doing offline configuration, you can select the motor that you're using with a drive. Here you can see the key factors of it. And mode select is where you determine how you're going to use the ACS drive. As you can see, the operating modes, we have index mode, analog position mode, pneumatic mode, Ethernet IP mode. Those are all the linear actuator modes. If I go back to actuator, to drive, one thing I forgot to mention is here's where you select the bus voltage. So you have 48 volts. Other options are 12, 24, 36. You can also configure for rotary operation, and that's where you would do this under the actuator tab. If you were driving a conveyor belt or a pump, you would select rotary here. Since we've selected Tolomatic, when we go to the mode select, we have these 4 operating modes. So the first one I selected was 4 move commands using 2 inputs. So that allows us to pre-configure 4 different positions, and those positions are selected in a binary code using 2 inputs. In my case, it's switches 3 and 4. We'll show that a little bit later in the mode select. Other options that we could use is we could use analog, and here we could select voltage or current, and the positioning of the actuator would be based on an analog input. This is quite often used for following dancer arms, to adjust dancer arms based on the position of a loop. Could be used for other applications where you want to monitor a sensor and adjust the position accordingly. In pneumatic operation, we have several different options. Spring is a single input to drive the actuator out to its second position, and when you drop that input, it would return like a spring would return on a pneumatic cylinder back to the home position. You can also have two positions based on two inputs, so if you turn one on, it goes to one end. If you turn the other on, it goes to another input. Three position, two input, like it implies, is there's a home position, or you can use the other two inputs to select the other positions. And three position, three inputs, each position has a dedicated input for it. We can also do Ethernet IP, which would be set up in conjunction with a Rockwell Automation PLC. I want to go back to index move. You configure your I/O, your inputs and outputs, on this screen. So I have set mine up for switch 1 to be enable. That enables the drive. Switch 2 is start motion. Switch 3 could be home, but I'm going to set this. I'm going to set switch 4 for move select 2, and switch 3 for move select 1. The reason why I had to reconfigure this was when I switched through the mode select options to show those to you, it cleared out my configuration. I'm going to set digital output 1 to fault to indicate faults should they occur. I don't have that hardwired in this case, but that could be wired back to a PLC if you wanted to. You have a digital input bounce control, so if you have a noisy signal, you can put in some filtering on it. If you have a break output, you configure it over here. Enabling the break, you can set response times for enabling and disabling the break, and whether it's active high or active low. You also set up your faults, and so you have faults for overcurrent, and your options are whether you want to stop the motion, disable the motor, or cause a fault, or stop motion without causing a fault. You can set up positive and negative limits. You can do a software stop, and also a position error, stop the motion. You have critical faults that are set up to disable the drive. We can set up safety limits for maximum velocity, XL decel limits, position limits, settling time, following error, and also current limits. These are default to limits based on the motor that's configured, but you can lessen those as well. And you can also set up software limits. We could adjust this down a little bit here. If we want to keep it below 5.5, so we don't overrun the drive. It goes up by increments of 1. We'll go up to about 5/4. For homing, you have a couple of options. You can do a home to a hard stop. Actually, that's the option for this particular drive. You can set direction. This sets the velocity that you home to. And we can try homing. I'll enable the drive. We can do a home. You couldn't see that probably, but the drive did move a very slight bit. The rod moved back to home, sensed the increase in torque, and then backed off. Finally, the final screen here that we want to look at is the mode setup screen, and this varies depending upon which mode that you have selected. It's different for the pneumatic, it's different for index, different for the Ethernet. Since we've selected the index drive, we set up 4 different positions in this table in the center. I've labeled them 0, 1, 3, and 5. It could be any alphanumeric label that you want to put on there. You can set up move types, whether it's an absolute, an incremental positive or negative. You can do a jog based on an input, homing, force, no action or stop move. I've set positions here of 0, 1 inch, 3 inches, and 5 inches to go to, some velocities, and accel and decel limits, and force limits. So we can go up, if I enable the drive, we can go up and execute the move. I'm at 0 now, so we wouldn't move. We can go out to 1 inch, go out to 3 inches, go out to 5 inches, return back to 0. You can also set up a software-controlled test sequence. So this is kind of handy if you want to be checking out the system, make sure of clearances, do demos. So we can start that. It delays because it's already at 0. Now it's moving up through the positions, moving back down through the positions. Those sequences can change, so if we wanted to do 1 to 4, then back to 2, excuse me, back to 2, out to 4, we can change that sequence. Now normally that would be based on digital inputs, so we're doing software controlled moves here. I can switch over to digital input controlled and set position 5, go out, move to position 3, move down to position 2, and then position 1. So that would be the way that it would normally hooked up to either PLCs or manual inputs switches. You see this motion manager, this allows you to operate the actuator from within the software if you're using the software controlled functions over here. So we can disable the drive. Down below you see there's a big stop sign. That's kind of an emergency stop. So if I were in motion, we can enable motion, we can start this here. I can hit the stop and it does a stop immediately. I have to disable and then re-enable before I can start again. Oops, enable. Other functions that you have are listed in this set of tabs or icons across the top. So besides the stop, I can set my home position, go to homing mode, and before I do that, I'll go out here to 5th position, and then I'll execute the home move. You can see it's going to be at a much slower controlled pace. So very slow retract to home. And then the homed indicator will come on. So now it's homed. I can do jogging, so I can jog out and jog back. I can do position moves to specific positions. So here I have a move, absolute move to 0 position. That takes me back. I can do incremental moves, either out or back. I have it set for 1/2 inch. And I have pretty high accel decel rates and velocity rates. If I slow that down to say 10 inches per second squared, you can see the increment's going to be much slower, much more controlled. So you do have that great ability to control things in Motion Manager. We also have a really nice tuning filter feature. So we can go through and adjust the system. Pull this down a little bit. to change our tuning parameters. Here you have your proportional, integral, and feed-forward gains for velocity. We can also look at the position bandwidth. When you order these from the factory, they come with defaults that are typical for the specific actuator that you're using, but you can modify those as needed based on the load that you're going to be running. And you can also do a test move down here. Here we have it set up to go out 3 inches and return. So we'll operate that. It's going to do some moves. It's going to take some samples. And after a period of time, it'll upload those. And now you can see we have a nice chart up here that shows our and this is for position bandwidth. So if I pull it over to the right, we're tracking actual position versus commanded position. Actual in red, commanded in green. It's very difficult probably for you to see, but if we zoom in here, you can see that the actual position is very close to the commanded position. There is an error, but it's less than 0.04 inches. So we're holding very tight positioning as we go through this system. We can zoom back out here to see our samples. So these are our moves, and the light blue is the error position. Pull that back over here. So a nice tuning filter feature available. Other features, we'll move things back over here. You have a digital I inputs and output screen, and it probably is being hidden back here somewhere. I tried to condense my screen so that I can get everything on here, and I think what I've done is wound up hiding it. I'll try clearing that off again. So I'm going to turn off the software here for a second and reload it. Hopefully that'll get it back in position. Adjust my screen size here. And cancel that. There's we go. Here we go. Sorry about that delay, folks. So we have an input-output screen that we can look at the sample of our digital inputs, switching them back and forth. So you can check digital inputs. We'll move this back here a little bit. We have an analog output, input and output determination. So as I change my pot, you can see the voltage is changing down here. We can select the units that we're using, US linear. You can also do it SI linear, so you change the metric. You can do US rotary and SI rotary as well. We'll stay with US linear. And then a final feature that we have available is a software oscilloscope. This you can set up to monitor different features like we did in the tuning filter, but this would be during just standard operation. So you could check for force that's being applied. You can set it up for velocity, a nice little handy diagnostic tool that's available. Now I want to show you back to one of the alternate modes that we have, going back to an analog position. Show you some of the flexibility you can have. We'll go with voltage. Go back to mode select, setup, mode setup screen. You can see it's different. Before we had the index, now we have analog. I have a 9-volt supply coming in. I've set that to be equal to 5 inches, 0 being 0 inches. We'll load up our motion manager here. And we can do software control, or we can do the analog input control. We'll enable the drive. It's already been homed. And I'll simulate an analog input so we can move the position out based on an analog value coming into the drive. So again, this could be based on a dancer position. Obviously, you would need to adjust the velocity, acceleration, and deceleration rates to get adjusted response. So you can see this is fairly slow response. We'll come back here and change the velocity. We'll crank it up to, say, 10 inches per second. Maybe go to 40 on XL decel. We can go back to simulate again. You can see the response is much faster. Obviously, that's limited by the capabilities of the motor and the actuator, but the Tolomatic sizing software will help you determine that proper configuration of actuator and motor combination. If we go back to analog input, we can enable it. Excuse me here. My pot's rather coarse, I apologize for that, but you can see I can manually adjust my analog input and get analog positioning. So both options are available to you in the standard basic unit. I'm not going to go into the setup of the Ethernet IP or Modbus because I don't have access to either of those PLCs in my present configuration. But we do have standard tools, software tools, as we mentioned before, that you can drop into your Rockwell PLC or a Modbus-based PLC device and communicate with the drives, giving them motion commands based on your PLC logic. So those are also available. I want to open it up for any questions that you have at this point in time. I'm going to try and get over so I can see those questions here.
Tom, right now we don't have any questions, and for those folks out there in the audience, if you have questions for Tom, please feel free to type them in the question panel, and we'll answer those for you. We'll give it about a minute, and if we don't see anything, we'll go ahead and close out the webinar.
While we're waiting for questions, again, we want to offer you our services to come out and meet with you to show you one-on-one the ACSI units. C&E has 2 demo systems set up. We can come out to your factory, to your offices, sit down with you, show you the demo, show you the software personally. Also go through the configuration with you of the various actuators that we can use this ACSI drive with. So those do include rod actuators like we demoed today, as well as rodless style actuators in several different configurations. So we have a lot of flexibility from that standpoint.
All right, we didn't see any questions come through. So Tom, I appreciate you hosting this webinar for us. Thank you very much. Good information. And we'll go ahead and close out the webinar. Everyone who registered for the webinar will receive a link to the recorded session, and that way you can view it at your convenience. So please join us next month on March 9th at 10:30 for John Pipkin's webinar on superior wireless communication for Internet of Things applications. Thank you, everyone, and have a good day.